Okay, before talking about the content of the lecture, so today's topic, I mean, just a couple of announcements, let's say, about the schedule of the course. Okay, so this is the updated schedule also for next week. Okay, so next week there will be lecture on Monday as usual. Okay, just last week we didn't have the lecture. There will be no lab on Fridays, 5:30 p.m. as announced, and this is valid, let's say, until the end of the course, unless something happens, like everybody comes to the lab. Okay, which is a bit, let's say, probably not so probable. Okay. I've counted you like there are, I guess, half of the course, half the people that are enrolled in this course, which is about 150, so half is more or less 70 coming to the lab, okay? Maybe a bit less. So we can handle this with 2 groups, and that's fine. And for the moment, this schedule that we have, is that we have this slot on Tuesday, 4 p.m. and the slot on Friday, 4 p.m. Okay, which is the more convenient one compared to the other. Okay, I will delete the other later. That's next week. I was wondering while I was in the lab, and I already told the students that were in the lab on Tuesday, if we can ask to book this slot for the lab. So in case somebody wants to stay, 3 hours long in the lab, maybe it's a bit more convenient, and of course we free this slot. But I need to ask the Politecnico administration if this is allowed. And of course, I mean, somebody said, well, we have the day full of lectures on Tuesday. That's true, but I mean, if you only come for 1 hour and a half, for your group in the lab, or one of the groups in the lab, you still have the break, let's say, just earlier or later, okay? So maybe you can think about this during the lecture and tell me something during the break, for instance. And so I can try to ask. I mean, it's not given. I need to ask, and maybe they have other reasons not to give this slot, and so I don't know. But I mean, if you agree, I will ask. I will try to ask. It's more convenient for us, for you, and for everybody. Should be, at least. Okay. So the second point I would like to mention before starting the lecture, I mean, the topics, is somebody has written, can I come to the office and discuss, the implementation of the labs and so on? Of course, I mean, everything is possible. We don't have, me and my colleague Antonio, we don't have specific hours, office hours for this activity, but we can have an appointment. But I would invite you, to use the hours in the lab, especially for this purpose. You can ask anything during the lab about lecture, about the implementation, other things related to the course and so on. Okay. So if you don't want to be heard by others, maybe we can move out of the room. I don't know. Okay. So I would expect that mostly we interact during the labs, okay? I will be present in most of the labs. Actually, unfortunately, again, there's a problem on Friday, but I mean, there will be my colleague Antonio, but which is, by the way, supposed to give some hours during the course, so it's no problem in this regard. And we can find time in the lab, and if it's really something that you cannot handle in the lab, of course, I mean, we're here to help you, and we will meet in the office on appointment, okay? So you write an email and you give some reasons why you need to, come to the office instead of coming to the lab, and we will arrange an appointment, okay? Okay, fine. So this is all for the announcements. And so if you don't have any questions about the last lecture, which I remind you was about the APIs, and some of you already experienced this stuff in the lab, and the rest of you will try tomorrow. You remember we talked about HTTP APIs implementation. They are just regular HTTP requests, so we just need to decide the URL. And today we will have a second part of the lecture in which we practice a little bit designing these URLs in the best possible way, and especially the implementation. We will discuss more about the implementation today. Okay, so some of you, the one who came in the lab already tested this REST client. I mean, this is just an extension of Visual Studio Code. It's just convenience. There are extensions for the browser. You can even do requests from command line, but it's very, how to say, inconvenient, right? You need to remember the syntax and everything. And this extension instead, we will try it today. Just press a button, okay? The little text that appears over here in Visual Studio Code, and you just send a request and see the answer. Okay, so it's much easier to use, to send requests. Okay, so let's come to today's topic, which is here, right? Which is more about how to design APIs, keeping in mind the security. APIs are a way in which the client part talks to the server part, and the server part answers with some data to the client part. So it's a place where data exchange happens, okay? And it's also a place where attackers can easily intercept traffic. Of course, we can encrypt the traffic. That's one solution. But since this traffic transits over a network, potentially over the internet, which is covering the whole world, so if you are able to, for instance, listen or check what's happening when you are exchanging information between client server, that's a problem, right? Or from the server side, that is the perspective from which we are looking at now, you receive requests from anybody, anywhere in the internet. Can be, next door, can be your computer next door, or can be the other side of the world, okay? Australia, whatever, I don't care. And so you need to be very, very careful about what they require you to do. Check the request, check if it's a reasonable request, and so on. And today we are going to talk more specifically about this, okay? And this will be checked at the exam as well, okay? Because you need to understand that, let's say, web applications are distributed applications. So they are running in two different places. One is the browser, the client. We are looking at application that runs in the browser. And the other is the server. And so they have a lot of problems because there are basically two programs running in two different places. Just for our convenience, they are on the same computer, okay? But typically they are in different places. One is remote, somewhere in the cloud. We don't really exactly know where. And the other is on our computer, the user's computer, the browser, okay? And distributed applications are complex because there is this asynchronous interaction between two different programs, the one that runs in the client and the one that runs in the server. Okay? And it's asynchronous by definition because they are two different computers. So requests, responses, and so on can arrive at any time. We don't really know. There's a network in the middle that can delay operations and so on, so we don't really know. So it's asynchronous by definition. And you saw that asynchronous operations are quite complex to handle, right? We saw it with the JavaScript. But here, we are looking at the problem at a higher level, okay? Not just programming, at a really higher level. There can be different clients requesting similar things to the server, impacting on the same resource on the server, and so on, okay? So it's not just about programming. So in short, this is more or less what we are going to talk about today. So in distributed application, there are quite a lot of problems, and since data comes from outside the application, outside the program, it means that it's by definition insecure. So we need to check if the request is valid, has the possibility, has the authorization to be performed, it requests something which is readable, so the input data looks valid, at least from a formal point of view. I'm expecting a number, and the number arrived, not a string, a generic string, and so on. Okay, stuff like this. Check permissions before performing operation. That's a big problem. I mean, for sure you're going to see this point again and again in later courses in your course of study. I mean, you need to be authorized to do the operation. I cannot just ask, the balance of somebody else's bank account, right? I mean, the bank needs to first recognize me, and then in subsequent requests needs to make sure that I am still the one who is still authorized to access the information, for instance. This is just access, but it's also to do modifications. If you buy or if you do other operation that involves, for instance, money transfer, which is the classical example because everybody thinks in terms of money. I mean, you need to be authorized to perform that operation, okay? And the server need to check this authorization, okay? Or can be something else. I mean, more something which is closer to you. You want to change, the final grade of the course, okay? And the Politecnico server probably will not allow you. I mean, I hope it will not allow you in case you don't have proper authorization, okay? We need to handle synchronization issues correctly because everything is asynchronous. So what happens if one client asks for something and then another arrives? And if the other arrives before me, I mean, everything is still working correctly? I mean, I need to consider the fact that requests can arrive at any time at the server from any client, okay? And also, last point, I would say, you also need to consider that communication may fail. So, some requests may never arrive to the server. For any reason, I mean, there has been a problem on the internet, somebody cut the cable, or you just lost a connection because, it was a wireless connection and you lost the connection because you moved somewhere else and so on, okay? So, you need to be able to handle all these situations, at least in theory. Now, we are going to see, some subsets of this situation in which we need to, the most common ones where we need to understand what to do and what to do in a correct way. There is a very useful resource in the internet, this OWASP website, Open Worldwide Application Security Project. Basically, it's a set of guidelines and articles and suggestions given by experts in security that tells you what to do and what you shouldn't do to increase the security of your applications, especially looking at web applications. Okay, just click. It's a very generic website, but we will have more specific links that will go into more details about specific topics like verification stuff. There are specific links later in the slides. Okay, so we will take mostly this website as a reference because a lot of security experts contributed here, but it's not the only resource, but it's probably one of the most important ones. Okay, taking from this website, these are the top 10 web application security risks. I just updated to 2021. I checked, unfortunately they say that we are going to release the 2025 half of the year, so they didn't release it yet. But it doesn't really matter to us. For us, the important thing is that there are quite a lot of common errors and problems that can happen in web applications. So here we are talking about specifically web application. You see, number one is broken access control. You didn't check credentials correctly in some places where it was needed. The example I was telling you before, you need to be authorized to perform operations and so on. And then, injection has been decreasing in terms of, probably I think this is a frequency of happening. We will see an example of injection. And, cryptographic failures, I'm not really sure what this really means in practice is probably using weak ciphers and stuff like that. Okay. Insecure design. Okay, we try to have a more secure design, etc. Okay. So point number 1 of my recommendations here is really understand that in web applications, incoming data, okay, both on the client and on the server part, well, mostly on the server part because the server is open to everybody, can come from any sender, from any part of the world, as I said. I mean, it doesn't matter that in your application, in your client, you decided to send this and you program the application in a way that it cannot send something else, okay? The server is open to anybody. Take the Politecnico web server. It answers anybody. I mean, there's somebody in Australia. I mean, I'm taking Australia because it's really far, but somebody wants to know something about the Politecnico, it goes to the website, okay? And that is not a web application, but maybe then it can log in, it can register to enroll in the Politecnico, and then it interacts with the web application. So, and requests can come from any place. I mean, the server doesn't really know what to do with the request until it inspects the content of the request, right? But it must accept the request coming from any place. Otherwise, you would not be able to interact with the web application, right? And since the data can come from any place, from anywhere, from anybody, every time there is incoming data, this must be carefully checked. Every time, okay? This is a major source of errors at the mistakes at the exam, okay? Thinking just in terms of your computer, your application and so on, your client application. It's not like you design a server just for your client application. It's not a standalone application on your PC where the only interaction you can have is with the local user interface. It's a client. It can stay anywhere. And also, I'm not forced to use the client. I, in the sense, I as an attacker, I can use, plain HTTP requests. Okay, I can use the REST client as I was showing you last time to do HTTP requests. I can use other tools. The only important thing is that I'm able to speak HTTP. That's all. Okay, because it's an HTTP server. So this is really important to understand. Okay, because when I point out problems in the web server at the exam, many, luckily not so many, okay, some students answer, but in my client, the user cannot. I don't care about your client. It's about anybody interacting with your web server. Anybody can send HTTP request, okay? Even authenticated user can take the authentication token and stuff, as we will see later in the course, and send requests which are not prepared by your application, by your client application. So the message, the basic message that must pass in this course is, incoming data on the server side must be carefully checked every time. Okay, every time. We cannot trust anything. Okay, until we know that, we inspected the request, and so we know that there is an authorization token, a cookie, whatever, and so on. So it's an authorized user and can do some operation. And then we checked, okay, we are expecting an integer. Okay, it's an integer, good. We are expecting a string, max length, and so on. Okay, that's good, and so on. And so then we can process the request and try to see if it, if it works or not, etc. Okay, so there are different levels to do these checks. We will describe them in more details in the following, but just to give you an idea, one, formal correctness. I'm expecting a number which is greater than 0. I mean, if something arrives and it's less than 0, -2, I mean, something is wrong. You're doing a login and you expect a username field not to be empty, right? I mean, how can I log in somebody for which I don't know the username? Okay, so this kind of requests, this strange request should be immediately blocked. I mean, there's no point in going on in processing such requests if they don't fulfill this formal correctness, the expected formal correctness of the request. And then it must be consistent with the application logic. So if I'm inserting, let's say, an object in a shopping cart, classical example, I mean, you interact with a shopping cart, you add an object, another object, and so on. You must make sure at a certain point on your server that this object that you are inserting, typically referring to it by an ID, exists somewhere in the database. Otherwise, you are just inserting IDs in a table and they don't refer to anything. And then what will happen to your application when you try to buy the stuff? Did you consider that? Well, I hope so. Okay, so it's better to prevent potential problems than to address them later. And then there are malicious requests. I mean, really plain malicious requests, like you know, I'm trying to register a new user, and I give a username which is not Enrico, and that's all. But my name is Enrico semicolon drop table user. Okay. Actually, my father and my mother didn't give me this name, of course, but you know, well, Elon Musk did something strange. I hope, well, at least it was not an SQL query, right? I mean, X, whatever, for his son. Anyway, but I mean, this is kind of just, you know, just for laughing a little bit, but I mean, you need to be careful because, you know, you're just asking input from the user, and that's probably the most dangerous situation, right? Because the user can type and can send any kind of data, okay? And so you need to be really, really careful when user can send any kind of data. Okay, and note this, I mean, this, we didn't speak about authentication yet. This will be the topic of the last part of the course. But I want to underline here, this also applies to authenticated requests. I mean, I already did the login, so I'm not just a random user somewhere in the internet. I'm a user who has a username and password, okay? But I'm a malicious user anyway, okay? You know that many attacks happens from inside the organization. So it's not just a random user. It doesn't matter. It's inside. So it's somebody that has a username and password and can access some systems. It's just that it cannot do something which is not authorized to do. Okay? And on the server side, we need to check this carefully. So it doesn't, it's not enough that you performed an authentication. So you enter the username and password and you have an authenticated session. Every time you have a request on an authenticated session, you need to make sure that the authenticated user can do the operation that is requesting to do. Okay? Okay, so a very long story for the introduction. Okay? Okay, that's what I just said. And there are also other points that we need to be careful about. Well, that's bad English. We need to be careful about also other system level issues. Okay, so it's not really just the application that can handle these problems. I mean, the rate of request should not be excessive. So if there are like 1,000 requests a second arriving to my server, well, at the server point, I cannot really do anything. I can just try to handle the request. If they are bad, I just don't answer. Okay? There should be something before my server that handles this situation. And in case it finds, you know, it's an excessive rate of requests, in some cases it doesn't pass them to my web server. Okay? But this is outside the scope of the course because it's not about web applications, so client and server. It's something that should be in the middle, okay? And of course, it's a problem. I mean, I'm not denying it's a problem. Indeed, it's for instance, the classical denial of service attack. I mean, many requests just, you know, to overload the web server, okay? But at the server level, I cannot really do anything. And indeed, this type of attacks, I mean, you will see in other courses are dealt with before. I mean, you need to have, let's say, a large bandwidth and a server that can easily check if the request is worth passing to the actual web server or not. Okay, so with simple logic, so you don't overload your server. Okay, that checks if the request can be passed along or not. A solution exists to handle some of these problems. I mean, we don't want to go into details here because, again, it's outside designing web applications. This course is more focused on just web applications, so how the web application works. And sometimes we will talk about security of web applications, especially when it's a critical part of how the application works. Okay, and indeed, the APIs for our web application are a really critical part because they are the way in which data is managed in modern applications. Okay, it's not like I load a new page and so on, like traditional applications and so on. It's basically everything about exchanging data, and so designing good APIs is really fundamental for our modern single-page application. And it's also the place from which we will start. I expect you to start in designing, the project for the exam. But I mean, in general, to design a new web application, where do you start from? You start from designing the API, the interface between the client and the server. Okay. Of course, you need to have a general idea about what the application is going to do. I mean, of course, but I mean, on this basis, you need to read some information, you need to write information, query information, and so on. You start designing the APIs, and then you will refine the project. But that's a starting point, and so you need to put the maximum level of attention here. Request to API can arrive at any time. Okay, never forget this. I know, it seems trivial on the slides, right? But then you work on your application, you have your server, your client, there's no other clients, no other client around, and you forget about the fact that can be another client, right? But web applications are multi-user by definition. They are different from standalone application. That's a user in front of the screen and using your user interface. Web application are multiple clients can connect at the same time and perform operation. That can be independent. I mean, one is querying the list of exams, the other is querying whatever what's the name in English? The list of past exams. Okay, so they are operating on different sets of data. That's fine, but can also operate on the same set of data. Okay. Typical example: you reserve a seat for the train, the plane, a concert, whatever. There's the same resource, and you need to make sure that the requests are handled correctly. You cannot give the same place to two different persons, right? To two different clients in this case. And so you need to take into account this. It's again another really important point. Also for the exam, that's something that we will check for sure. You should attend this course and pass this course, knowing that, I mean, we have a distributed system where there is one server, one logical server, and different clients, and they can act together at the same time. And you need to be able to handle this situation. Always think in terms of multiple users, multiple clients, and concurrent requests. Okay, so this means that there should be no global variables or global state in the server to handle client requests. I put this, I thought it was obvious, but I've seen, a couple of times in the last 5-6 years giving this course. Before giving this course to cybersecurity, it was given to computer engineering, okay? And it's still given by the colleagues there. And, sometimes somebody thought, well, I'm going to store some information in a global variable in the server. Okay, that's something. I mean, index.js, the stuff that you used in the lab or we will use today, and you run the server. Somebody had the idea to store information in a global variable. I mean, this doesn't work. I mean, you have the database for this purpose, and in the database you can tag any information you receive with the user, okay? So if it's related to a user, you need to add the column user, that is the owner or whatever it's related to that user and so on, okay? You cannot simply put information as a global variable in the server, because you need at least to know from which client it came from. Right? So, I mean, if I see stuff like this, I mean, it means that, I mean, you don't know what's going on in the server. So, I mean, you cannot pass this exam about web applications in this case, okay? I mean, but it is quite, let's say, unusual situation, like, luckily. I mean, the more likely situation is that you forget that it's a multi-user application, right? So maybe in the server, you don't add the user information when it's needed, or you don't think in terms of multiple users that could do the same request. That's more common, right? Okay. No assumptions on the order of arrival for API requests. Like, I need 2 operations on the DB to perform a certain action. We will see later, for instance, I'm bidding, an auction, you bid, so there's a current value, and you bid, to add some money with a higher offer to buy something, for instance. You cannot simply read the current bid. Well, decide, well, I will add €1 and I will store the new bid. That's wrong. Okay, this example is present in the slides later. Because if somebody else reads and decides to bid €5 more, you should end up having, the offer at €5 more, not just one. Okay, so you need to think in terms that can be multiple clients in the most let's say, unlucky situation, and you need to be able to handle these cases. Okay. And last recommendation is remember that how the backend is implemented, it's independent from how the client is developed. Now, today, in this course, we are going to use this Node.js, JavaScript, and so on. I mean, any technology can be used for the server. Probably there are better technologies because, we are not using frameworks and stuff on the server. We are just using Express to handle the protocol, and we will use another library for the authentication. But, I mean, we don't really care about how things are implemented in the server as long as we have a clear contract with the server, and this contract are the APIs, what each API does, and so what is the format of the request, and what is expected as a response. And that's why it's so important to design good APIs for your application. Okay? Okay, good. So we'll go into more details about the points I mentioned before. And then we will see some demos, I say, of some problems that can happen in the application, and we'll try to develop some APIs for a sample application that we will start basically today. Okay, so formal data correctness. Actually, there are no general rules. I mean, because APIs are specific of a certain web application, so it depends on the application. But I can give you examples just to make sure you understand, you get the concept. Okay, like you're expecting a number of items to buy. I mean, this should be a number. I cannot transmit the word, I don't know, some words. I mean, my name or stuff like that. It must be a positive number. -3 is not an acceptable number, right? But this depends on the application logic. I mean, it's the application logic that defines what is acceptable and what is not. Other examples, I mean, exam code, I mean, at the Politecnico is 7 characters, okay? And I would guess that the first 2 are numbers, digits, and the other are letters. But actually, I'm not sure. I mean, actually, you should check the specifications. I'm not sure if they have specification. I hope so. When they developed the application, a web application entering the exams at the Politecnico, they made this decision. Okay, we have a 7-character exam code, and the first 2 are numbers and so on, digits. This is a decision that has been taken by the ones who designed the application, or maybe even before, and the application has to must be conformant. Must comply with this rule. Okay. If you have freedom, you decide the rules yourself. If you don't have freedom, you check the specification that were given to you. Okay. And so there can be no exams with 8 characters code. If I get a request for checking, I don't know, the name of that correspond to a certain code which has 8 characters, I should refuse the request. Okay. There are plenty of other examples. I mean, typically, every time you have a fixed format for some value, you should check for the correctness of this format. Okay, at least if it's simple to do. Okay, like the zip code, for postal addresses. Well, the Italian one is just 5 characters, only digits. Okay, and different countries have different formats. Another example, a string that must be a valid email. Like you require an email to log in. Okay, and you need to make sure, well, the string is not empty. That's minimum stuff, but it's an email. Okay. All this stuff is really tedious to implement. It's boring. Okay. And so I encourage you and I suggest you that also from the security point of view, using software prepared for this purpose, so this middleware to do these checks of formal data correctness, it's really helpful in terms of, not to be bored too much about implementing this stuff, but also from the security point of view, which is the most important thing. Okay. Because the more code you write, the more code you can get wrong, basically. So, for instance, I recommend you to use this Express Validator. It's a package, an NPM package. It's really intuitive to use. It's a declarative validator. You can check easily stuff in the request that your web server receives, either in the URL as parameters, so in the variable part, colon something, okay, column ID, and so on. Or you can check content in the query or in the body. Okay. It's very simple to use. It's better to start from examples here. It's useless that we go here and check, all the methods and stuff. Basically, you import the package and you get some methods, predefined methods. Check. You put the name that you expect to receive. For instance, in this case, it's in the body. And then you have a lot of methods, useful methods, to check, for formal data correctness, at least for simple cases. Okay. Check an email. If it's an email or not, well, that's a method which is already implemented. And then, of course, you need to decide what to do in case there are errors. So there is this validation result function to call and check what to do if you find errors. Okay? Because when you find errors, it's up to you to decide what to do. Does your API answers, not found, or internal error, or wants to be more specific about the error? That's up to you. Okay? So you need to decide what to do here. Just think, last example was the email. Okay? The email looks simple, right? Some some characters, the @ sign, and a domain, right? So a dot somewhere. It's not as simple as this, okay? If you go and check what's the specification of a valid email, that's an RFC that says how an email should be formatted. So what is a valid email and what is not. You see some examples. Of course, they are quite unusual examples, okay, just to scare you a little bit. But these are valid emails. Maybe somebody used it. For instance, the plus sign. Did you think you allow the plus sign in the email? I mean, it's used by Google and a lot of other email providers, yeah, space and the quotations and stuff like that. Okay, these are all valid emails. And well, this is a provocative, of course. I mean, did you think about all these cases? But the point is, do you really want to spend your time to manually validate all these cases? I don't think so. I think you have enough to do for submitting the project for the exam, thinking in terms of the application. I mean, just checking an email is so common operation. Of course, if you have a really special kind of data and so on, you will have to spend some time implementing your own validator, because it's just you and your data, and it's a really specific kind of data. But for stuff, very standard stuff, email, dates. I mean, dates. Everybody uses dates. I mean, we don't really need to check if the year is four digits and so on. It's a leap year or not, and whatever can happen to these years, etc. Okay. URLs, float numbers, credit card numbers, where we don't care too much, and whatever you want, tax code, etc. They have a specification. I mean, it takes time to get these validators right. Okay. And so just use libraries if possible. Good libraries, I mean, not really the 0.0.1 version of some unknown library somewhere, okay, because it's probably not good code. You need to trust the code you use, and this is another problem. We spoke about this when we talked about the packages, right? I mean, if you really care about trusting the code, there should be somebody, even more people, that checks the code. Okay, there's no other way. And then just use the code that has been checked. And these validators can be code that has been checked, if everything is working correctly in your organization from the security point of view. Okay, so validation. We talked about formal validation. Use validators if possible. If not, I mean, if the data depends on the logic of your application, well, you're always free to write your own code. I mean, you need to check that the third letter is a digit and whatever, etc. And okay, write your own code. Okay, data consistency. So again, only the application, so the logic of the application knows what is acceptable and what is not. The point of this slide is avoiding that some request leads us to an inconsistent state in the database that we have. Okay, so it means there are foreign keys that do not refer to anything. As I told you before, there's an ID for an object that doesn't exist in the database. Or there are other inconsistent DB states that depends on your application. I mean, you want to have people which can buy only one ticket. I mean, each client can only buy one ticket. That's a requirement of your application. And so having two tickets for the same client, it's an inconsistent DB state. It depends on your application. Really, it's not about the DB. Yeah, there can be, DB constraints, that's fine, but I mean, it's really about the logic of your application. Okay, so let's see this example. Example number 1. It's an application that handles posts like Facebook, like whatever, Instagram, whatever. We don't really care. I mean, you post something and people put comments attached to this post. You need to make sure that when a new comment is created, the post ID exists. Okay? Otherwise, you end up with something in the database that is useless, and basically it pollutes your database. Okay? You need to store that information because you didn't prevent the information from going into the database, and basically you don't use this information. This is a really trivial case, probably without big effects on application security. But in general, you would like to avoid these situations, right? Because maybe at a certain point, you query all the comments and you want to print the post to which the comment is related, and maybe your code can crash because you don't expect there is a comment which has been attached to a not existent post. Okay? So you should avoid these situations in which you have inconsistencies in your state on the server, which is basically the DB for us, okay, and for most web applications. So, in short, how do we handle situations like this? Well, actually, we need to prevent those situations. And the way of preventing it is running code on the server side, on the callback that is called when the request arrives. We know that we want to create a new comment, okay? Before creating the comment, we check if the post ID exists or not. For instance, we can write some code like this. I mean, this is just examples, not really actual code, but just to give you a rough idea. If the post ID exists, okay, so perform the insert of the new comment. Or maybe in this specific case, sometimes you can delegate these checks to other places. Like most of the database systems, if you create a foreign key constraint, they fail the insert if the ID, that is a foreign key, does not exist. Okay? It's possible to use this approach. It's also mostly fine for the exam as long as you are able to explain it. Okay? Because you are basically moving the complexity out of the code of the server side and put the complexity inside the database, which is sort of fine because, I mean, the database should perform its work, which is also ensure some consistency in terms of foreign keys and so on. But at this point, you need to remember that you're not just programming the server, but you are also programming conditions in the database. So the database conditions are also part of your web application at this point. Okay? So either you keep everything in the code, or if you put constraints and stuff in the database, you need to remember, I would say, document this behavior. It's not just about the exam. Okay, the exam, you're here besides me and you explain it. But then you go and work somewhere, you put these constraints in the database, and then another programmer arrives and tries to modify your code and so on. You didn't document the fact that there was this constraint in the database. It tries to code something, doesn't know about the constraint, and the code does not work, and there's no explanation. And you need to debug for 1 day, 2 days to understand what's happening. Okay, so just be careful of these situations. Okay, but from the point of view of our application, from the point of view of security of the API, in this case, it's enough that we don't end in an inconsistent DB state. Okay, and this can be done, for instance, by checking if the operation would lead us to an inconsistent DB state, and do not perform the operation in this case. Okay, so an if in short. Okay, second example, there will be, I think, 4 examples. Okay, the application says you cannot insert more than n items in a shopping cart because it's, I don't know, it's a Father's Day like yesterday and you are limited to buy 2 things, I don't know, because there is a special discount. Okay, so 2 things. Okay, fine. So you add again something in the cart in this time, a certain item, so you still have the same problem as before. You need to make sure the item exists. Okay, so this is a foreign key to check in the database, basically. But in addition, before inserting the item in the cart, you need to also check if the application constraint is satisfied. So if you say the text, the specification said maximum 2 items in the cart, I mean, you cannot insert stuff and then say, well, oh, now I have 3 items. Okay, you need to check it before. So if the number of items is less than n, okay, you can insert it. So it's just an if, I mean, just normal checks in the code. Or again, some of you likes SQL much more than me. Okay, so there are people coming at the exam with SQL like this, I mean, multiple lines and stuff. Of course, I mean, SQL can provide you some flexibility in doing things. And I mean, the SQL parser of SQLi3 is pretty good. So you can write complex queries and have them executed correctly. And so you can also write, more complex SQL stuff to make sure that the constraint is satisfied. That's fine. Okay, as long as you can express the constraint in some ways in SQL, you can do it. But again, for the exam, sorry, I'm always talking about the exam, so I have your attention. But for the exam, you need to be able to explain that this condition was checked in the SQL. That's fine. Okay, as long as you know what you did. Okay, and it was correct, of course. So, because maybe I'm typically looking for code, right? Because you program code for the server side. But, I mean, you're free to use the various possibilities that you can have as long as you know what you did. Okay, third example, SQL injection. You might have heard about this. I mean, it's pretty famous. This kind of attacks are like, I think, more than 20 years old. And so it's just the stuff that I showed you before. I mean, when you ask for information from the client, so from the users, typing in a form, typing in a text area, where you ask for some information, first name, last name, address, I mean, the text of the post, or the comment, I mean, stuff like that. Anybody can, I don't want to say write, because it's not about writing, it's not about client. Anybody can send any information to the server through your client application externally, without using your application, using another program, the REST client, the command line, whatever, speaks HTTP, it can be used. Okay, and it arrives on the server side, and then you use this information, and this information needs to be put into the database. You need to be careful how you perform this operation, because if you write a query like this, db run insert into etc values plus, or with the backticks, the template literal of JavaScript, expanding the variable content and so on, you end up with a single string to be executed, and it will be interpreted as SQL command from the database. That's SQLi3, but can be also any other kind of database. Okay, so basically the executed query is insert into user, etc. values, and then you concatenated the value. Okay, so it's just part of the query. Let's assume you can run 2 queries in a single operation. Okay, just for simplicity, just to show something simple in the slide. And you will insert as fine, and then you will perform an operation which is not wanted. Okay, drop table users. That's the simplest thing you could do. Just delete data, just create inconvenience to the administrators of the application. Okay, deleting data. I hope you have the backup, right? That's what they recommend, and so you need to restore the backup after you know that this has happened, and you probably will lose some data because you don't, if you don't stop this immediately, there will be, other users that operate on the database and so on. So, I mean, you end up in a very complex situation where basically the information needs to be restored manually if possible. Okay? So, SQL injection is really risky, but it's also quite easy to prevent, luckily. Okay? And the typical way is use parameterized queries. It's not just because it's nice to write, the SQL because in this way we can easily substitute the values. This way of writing the queries, that's for SQLite 3, but it's very common also for other kind of databases. Maybe they call prepare statements or stuff like that. Basically means that the SQL command is separated from the data. So the data will never be interpreted as SQL commands. And that's good, okay? Because it's sent in a different way to the database engine. And so stuff like this will not work in terms of, deleting the table. It will simply add what was asked for. I mean, there will be a user named John, the semicolon, drop table, etc. Okay? But I mean, yeah, you end up with this database that contains a user with this name. Well, it doesn't matter. Okay, if Elon Musk comes and writes eggs and stuff, I mean, it can register on your website. Okay. Okay. Fourth example. I mean, it doesn't have to be SQLite injection. It can be any kind of injection. When you are able to put some code and you have a path that leads to this code to be executed somewhere, you have a problem of injection. It's not just about SQL. Okay? For instance, let's see the name of this other user. The name of this other user, John script, act script. Okay? This stuff, I mean, the database doesn't really care about this stuff. It's a string like another one. I mean, don't really matter. The point is that when it will be shown to the user in an HTML page, this tag script and /script includes code, JavaScript code that can be executed on the client side. So you will have a side effect that is not expected. You're executing code on the client side that you don't want to execute because it came from the user and it cannot be trusted and we don't really know what it's going to do. Okay? Of course, here you need to know how does HTML works, and the JavaScript, how to write JavaScript code in HTML and so on. But it's just an example of other stuff that can be put as injection, okay, in your APIs. So basically, what happens is that when at a certain point you will have another API that lists the name of all the users. You have a list of users and you have, let's say, normal names. At a certain point you have this name where there is this script, and this script will be executed and it will perform some operations. And this is really, I mean, basic stuff. I mean, it just shows a window, okay? But you can do much more complex stuff and much more malicious stuff, okay? Luckily, again, these injections are quite difficult to I mean, it's very difficult to make them successful because luckily most of the frameworks today, including React, prevent the execution of the code in this way. So when you have parametric parts of your page and they are loaded with data coming from other sources like database and so on, the framework prevents avoids that this data is interpreted as code from the browser. Okay, it will be quoted or changed in a way which is innocuous, so it doesn't create problems to the browser. Okay, but again, a more comprehensive approach is needed, and we will talk a little bit more about this a bit later in this course. Okay, so basically the HTML injection, let's call it this way. So you saw different example. This is just data consistency, okay, or some strange data, okay, that can create problems. And then there is the issue about security. You need to be able, you need to have authorization to perform the action, okay, permission in general, okay. As I told you in the end of the course, we will talk about this in more details. But let's say you're doing an operation that permanently changes the data on the server, like a delete, okay? That's fine. I mean, that's not, I mean, if your application allows to do this operation as a normal usage of the application, it's fine. But you cannot just delete anything you like, right? You typically delete the stuff that you created yourself. I'm talking about a generic application, okay? So let's say the comment before, you added a comment under a post and you want to delete the comment, but typically you should be allowed to delete only your comment, okay? You made a reservation for the plane, for the train, whatever. You can delete your reservation, but just your reservation, not another reservation, any other reservation. And actually, you see that the reservation is typically identified by some number, some IDs, okay? I mean, it doesn't have to be a number. It can be a unique string, okay, an ID. And, okay, and then you're sending a request to perform an operation like delete on this item identified by this ID. It's fine. But can you do this action? We don't know. The server needs to check. Okay. I mean, to understand this example where permission or authorization is performed, I mean, we need to assume at this point in the course that the server knows which is the user connected to the authenticated session. So basically, other operations have been performed before to show that you are able to do this operation. So the login, in short. So you logged in, so you provide the username and password. So the server gave you some secret information that you send for each request where the server needs to recognize you. So it knows that you are allowed to do the operation, and it allows you to do the operation, okay? So it performs the operation. So, I mean, this is typically done via token or cookies. We will talk about this again later in the course. But, I mean, the point is that there should be another check in the server. Like before we were checking for the formal correctness, then we were checking for DB consistency. At this time, we are checking for authorization. Okay. Again, you can do it through code. If the reservation of this ID is the user that claims to be the user, perform the operation. Okay. Or you can embed it in SQL as well. It's fine. It depends on the implementation that you have. You can have joins or whatever. I mean, I don't really care. But at a certain point, there needs to be a check where you check that the owner of the element that you are deleting is actually the same owner that sent the request. Okay? So, next slide is, this is really a major source of errors of exam. So we are taking out a lot of points for this stuff. I mean, not in absolute terms, but I mean in general, because a lot of people think that since I am authenticated, I can do anything. No, you cannot do anything. It's not enough like I authenticate myself on the Politecnico website and I can change the mark, the grade of any students anywhere in the Politecnico, right? I can only insert and change the votes for my courses, right? So there is some code somewhere in the server that checks that the course belongs to me. Okay, I'm giving the course this year, so stuff like that. Okay, it's a bit more complex, right? But I mean, you need to be the owner of that data, or I mean, better said, it's not about ownership, it's about permission. You need to have permission to do the operation that you are requesting to do, okay? And the server needs to do this check. So a very common error is thinking that since the user is authenticated, it can do the operation. No, I mean, it's not enough being authenticated, okay? Also, because of what we said before, malicious users can also be user authenticated in the system, okay? It's not enough to say my application, the client part prevents from sending that request. I don't care about your application. That's the answer at the exam, okay? I don't care about your user interface. Anybody who wants to perform malicious action will not use your user interface, okay? So, yeah, of course, naive users that don't know what to do, they click in the interface, it's fine, okay, you stop the naive users, but it's really easy to stop naive users. I mean, they don't know what they do and what they are doing, I mean, okay? So, really, this stuff has to be done for each request. Again, because each request is independent. That's HTTP. Each request has each HTTP transaction has a request and response. Okay? And the next one is independent. So another check has to be done. But actually, you write this code once for each API where you need to do the check, and that's all. And the server will execute this code every time it receives a request that matches that API. Okay? But the important thing is that you need to remember that you need to check for the user, who the user is, and if it has the permission to do the operation. Okay? Otherwise, I can delete the reservation of anybody. Okay? And just guessing IDs, I don't even care if the ID exists or not. I mean, the API will look for the ID. If it exists, it will delete. If it doesn't exist, it will give an error, but I don't care. Okay? So I can just delete random reservations. Synchronization, that's again a difficult part. Okay? Because, concurrency is always difficult. It's one of the most difficult things in computer science, right? So, remember that the backend implementation is independent from the client part, and it's also multi-user. Okay, so there can be more users doing operations on the same shared resource, booking on the train, on the plane, in the theater, and so on. Okay, buying items from your storage and so on. So you only have a limited number of items, and you cannot oversell items. At least if in normal conditions, okay? So, all actions that may change their output due to the potential interference from other actions started by us or by others, we don't care who starts the action, should be requested using a single, just one API call. I gave this example before, the auction. You bid. I mean, I want to buy this item. I offer 100 euros, and somebody else offering more, 110, 115, and so on, okay? And this works as long as the offer is performed in a single API. Otherwise, you see what happens. This is the wrong way of implementing it. I read which is the current offer, I offer more, and the point is that I'm overwriting because the put updates the best offer. So I'm overwriting the offer with a new value. Okay? So that's wrong because if another client does the same between the two calls, so I read 100, another read 100. Okay, I'm offering 105 and the other is offering 102. Okay, so less than me. So one read, the other read, one writes and the other writes. And I end up with the offer 102, which is wrong. It should be 105. And why this happens? Because you shouldn't do this operation in two different HTTP transactions, two different requests to the server. It should be just one. It's the server's task to decide how to handle the operation and check the current value and if the new offer can be accepted or not. Again, this is again a major source of errors at exam. Thinking that nothing happens between different calls from the client to the server. Okay? So, how do we fix it? Design a single API. So this is a problem of designing APIs. Okay? If you design an API where you have the put, that's wrong. You cannot update this stuff from the client side. It's fine to have the get because at a certain time probably I want to show the current offer. Okay, it's fine. I mean, the get is neutral from this point of view. Just reading is fine. But the put is wrong. You cannot just decide which is the new value. The server decides which is the new value. You send the offer, the new offer, and the server decides if it will accept the offer or not. Okay? It's only the server that can decide if it will accept the offer or not. You, as a client, you cannot decide that is the new offer. You can propose the offer, okay? And the server will check and decide. But in a single API, because in this way, either you arrive first or you arrive second, okay? If you arrive first, 105, the second arrive with 102, it says, well, it's already 105, rejected. I mean, we don't care. I mean, that's not possible to offer 102. If you arrive second, that's fine, because the other arrives with 102, you arrive with 105, the server accepts it, and it will be 105. So problem solved. But it's a matter of designing the APIs, okay? And also note, typically these issues can only be solved with the post-transaction, HTTP post-transaction, because the status of the server will change, and it will change again, potentially, if you send a second request. Okay? You don't really know if the outcome of the request. It's not like the update. The put expect if you send a second put exactly the same way, you get the same value. But this is not the case because we don't know what happened. Okay? So it's wrong designing the put, using the put for this operation. Okay? And the client also shouldn't care about these problems. When I hear at the exam, again, sorry, so always talking about the exam. That's almost done, but okay. I did 2 requests from the client, one for reading, one for... It's wrong. I mean, the client shouldn't even think to do these 2 requests. The client should think to just use the API. It's a problem of designing the APIs. That's why we start, at the exam by reading the APIs of your application, even before opening the application. Okay? Because we think in terms of what is the information exchanged between client and server, and how you implemented or you could implement the operations. And then we will check how the application works. If it's nice, I mean, not really nice, and don't care too much about the aspect, but I mean, if things gets updated correctly, okay? So, just for this course, this is important, only for simplicity. Sometimes you might need to run more than one SQL query in the same API, but that's always the same API, okay? And here we assume that nobody comes and run other queries on the server, okay, in the middle. So it means that if there are other requests from other APIs, they get queued and they wait for our API to finish, which is actually also what is happening. But most of the time. But I mean, otherwise, I mean, there is a way to solve this problem. You need to make an SQL transaction, okay? But we are not requiring the transaction just for the exam, okay? But for sure, we are requiring the API, the single API, because that's really a flawed design, a wrong design, having two APIs instead of one, okay? And then when you have one single API, we assume that when you are inside the code of one API, the database is yours. So you start from a consistent DB state and you arrive at consistent DB state. That's enough, okay? But just for this course. Otherwise, you know, codes on the server side becomes more complex. You need to handle the transaction, the rollback, and so on. It can be done. By the way, somebody at the exams also tries to do that. It's not required. We cannot give you additional points for this. And but I mean, we don't really care too much, okay? Because basically, you could simply, let's say, start the transaction at the beginning and then the transaction at the end of the APIs, and you solve the problem, okay? More or less. I mean, you still should decide what to lock, but I mean, don't want to spend too much time. So how to implement it? Well, again, if you are like the SQL wizard, you can write everything in a single SQL. There are people, as I told you, that do that. But sometimes it's difficult because you need to check a lot of conditions and stuff that can only be checked through JavaScript code. So, I mean, no problem. We run different queries. And we assume that there is no interference when running these queries because we are in the same API. Okay? Yeah, we are almost done and then we break. Other examples, because it seems that everything is a reservation. No. You know, there are many places. Basically, every time you think to update a state on the server, it depends on the previous state, okay? You need to be careful. Do it in a single API on the server, because updating a state, depending on the previous value, it's basically saying that I need to read and then I need to decide what to do. So there are two operations. Always use the post and just implement the operation correctly. Like, you know, increment a counter. It seems trivial, I mean, but if you don't do, you know, if you do the get put and you don't do the post increment, okay, you lose increments. You might lose increment because the second put might override the value of the first put, okay? It's just a counter, okay? It doesn't matter that much, maybe you can say. I mean, we are looking for correctness of APIs. We are looking at understanding the concept, okay, that lead us to correct web applications, okay? And in other places, you can run it into physical problems, like, you know, you book the seat and you book the same seat for two persons, and then they meet on the train and what they are going to do, or the plane, etc., okay? Or buying items, okay? Especially when physical things are involved. I mean, you cannot just duplicate items. I mean, I buy a mobile phone and I only have one in the store. I cannot sell two, okay? I mean, it's a kind of crime, right, to sell two. So basically, every time there is an operation that involves, you know, a new state computed on the previous one, you need to be very careful. It's a matter of synchronization. Just say what do you want to do through the post and let the server handle the situation. Because the server is the only place which has visibility on what every client is doing, okay? At the level of the server code or at the database level, okay? Okay, so basically we finished this long discussion, okay? Here you find a few links to these cheat sheets that are basically a list of checks that you should, you know, have in mind when you want to check for security in websites and so on. But I mean, from the point of view of our application, I think of our course, I think I highlighted basically all the security issues in which that we need to handle in our basic web applications, okay? And basically everything boils down to say design good APIs. Once you have good APIs, the rest should follow more or less automatically, okay? So if you have questions, I'm glad to answer. Otherwise, we'll break for 10 minutes, something like this. And I'll prepare, the examples, which are, by the way, already on the GitHub. Okay, so next hour and something, we will have a look at the examples. Okay, some injections and some API design. We will design some APIs together. Okay, no questions. So let's break for a few minutes.